Hey gang, so it is time for Calculus Unit 5B. So I know the packet is pretty hefty again, but think of it like it's our book since we don't really have a book. So we're going to start off with stationary points. Okay, this is kind of a takeoff of Algebra 2 and Algebra 1. You did these back then. Stationary points are when you have a graph and when you look at it, you're like, oh, well, there's the y-intercept. You know that point. Now, it doesn't mean anything on this other than that's the y-intercept. But you do know that there's a point up here where this graph comes up. Let me turn this light on to kind of help out a little bit. Oh, okay. Well, I'm going to turn that off because that was too bright. It comes up, and this would be what we would call the maximum point. It's the highest point. And if I did it on an interval from, say, -5 to -1, that's the highest point. And then as the graph continues on, it reaches a low point, and we call that the minimum point. So we have the maximum and the minimum point. So when I talk about a local maximum and a local minimum, I'm talking about the highest point and the lowest point. I could ask you, what's the local maximum on this right here? And you could tell me that ordered pair, or you could figure it out. If we could graph it, we could put a part of it on each side of our calculator and calculate the maximum point, and we could find it. But for calculus purposes, when you have a local maximum, you want to think about it like this. This is where we're always talking about tangent lines. Tangent lines have a derivative. That's the derivative. It's the slope of the tangent line. If I had the highest point on this interval right here, the tangent line would go right across, right? And in calculus, we're always talking about the slope of the tangent line. If that's the tippy top, what would the slope of that line be? It would be 0. If the slope is 0 at that point, I would write that as f prime of x. That's the derivative. The derivative is the slope. At the local maximum, it equals 0. Now, we'll do the local minimum. Well, here's the minimum. If I were to draw the tangent line, what would the slope of that tangent line be when you're at the lowest point on the graph? The local minimum. It'd be the same thing, right? The derivative would equal 0. So f prime of x would equal 0 again. Now, let's see. A horizontal point, what were the other? Horizontal point of inflection. Okay, so let me explain these, and then I'll go back and pick that up. This point right here is an inflection point. This point right here is an inflection point, the actual point where the graph is changing. All right. What I want to show you on these points, I'm trying to find a good pen. I think this is my blue one. Remember, we read from the left to the right. As we're coming up, when you reach a maximum point, I was increasing, right? And when you reach the maximum point, it changes, and now I would be decreasing. So I know we did pink for increasing earlier, so I'm going to do, I would be increasing, and then when I reach the top of that graph, I would change, and I would be decreasing until I reach that point of inflection, and at that point, my graph would change, and it would go up. So what I want you to think about is, when you have a local maximum, you don't know anything about the graph, I just tell you, it has a local maximum, and this isn't correct, but we're going to use it. At -3, 3, there's a local maximum. What can you tell me about the graph? Well, you could tell me that the graph was increasing until it got to -3, and then it turned and it was decreasing. So what I want you to know is if you have a local maximum, you have a sign change. And this is in the slope. We're talking about the slope now. The tangent line, the slope of the tangent line as you approach it would be positive, right? It would go from positive. Oh, I should have put change, sign change, sorry. From positive to negative. The slope is positive, 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 positive. It hits that inflection and it turns and it's negative, 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 negative. And then it turns and it's positive, 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 positive. So as you're going on a local minimum, as you're going towards a minimum, you're going to be going downhill. So you're going to do a sign change. Negative, 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 from negative to a positive. All right. Now, what happens at that point of inflection? At the very tip top, the derivative f prime of x equals 0. That's our point of inflection. And at that point, if we're just looking at that point, the derivative of 0, the slope without the tangent is 0, but there's no sign change. It's just you're sitting there. It's one single point. It's a point of inflection, so there's no sign change on that. So I'm going to say no sign change. Okay, so here's what I want to do. I'm going to zoom in a little bit because I can't see that very well. Oh, that's better. Okay, identify and classify the stationary points on the graph. And there's my function. And here is my graph. Okay, how am I going to do that? Well, I could go and, calculate the maximum. I might not know if there's an inflection going on right here. It's turning, it's going down, 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 but then it kind of levels out. But I'm not sure if that's straight and then it goes down. The only way to really be sure of the way the function is going is to truly take the derivative of it. And the derivative is going to tell me all kinds of things about it. So here's what we're going to do. We're going to take the derivative of this. So I'm going to give you a second to do it, and then I'm going to do it. All right, here we go. I'm going to have to look up here. 5 times 4, yes. 5 times 4, I can't even see it. It's so small. 20x to the 4th. And then I got minus 180 x to the 3rd plus 360 x squared plus 80 x minus 480. If you need help on the derivative, you can come to class and watch us do it there. All right, so what I'm going to do, I need to look at this, and I kind of need to break it up into intervals so I can see what it's doing. Let me get my calculator out here. All right, so I'm going to go ahead and put my derivative in my calculator. Give me just a second. 20 x to the 4th minus 180 x to the 3rd. Oh, I did that, didn't I? Hold on. I do that all the time when I'm working these. I forget that I need to move my little calculator thing over to the side. 180 x to the 3rd, move to the right, plus 360 x squared plus 80x minus 480. Okay, let's graph that. Now, there's something I want to show you on here. Notice here how it's kind of difficult to see it. So what I'm going to do is second table. I probably need to do a whole video on this just separate. I noticed that these y values are pretty big, 2,500 and negative almost 500. So what I'm going to do, I'm going to go here and make the max of this 2,500, and I'm going to make the minimum negative 500. But those are too big, so I'm going to scale it by 100, meaning my graph is going to go by hundreds up on this side. And if you look, this goes by 500. So maybe I even want to do 500 on the y. Now on the x, I notice that it only goes out to 7. So maybe I'm going to make this one go out to 8. And it only goes to negative 2. So maybe I only want to go to negative 5. Kind of set your graph on here the way it is here. So now when I graph it, doesn't it look a lot better? It's a little easier to see. So remember, I'm looking for those stationary points, the points where the graph has a slope of 0. How do you find those? Well, we need to look at our intervals. I'm going to show you my intervals. I'm going to start at -1 because I'm noticing a high right there. We're going to go from -1 to 0. And let me do it on here. It'll probably make more sense. Let me calculate that 0 right there. Second, calculate the 0. Let's go back up here. Enter. 1, 0. -1, 0. That means that at -1, 0, you have a turning point. Okay? If you remember when we were doing these earlier, that means that's where the graph changes. Remember how we said if we were up here, the graph was increasing, increasing, increasing because it's positive, and then it turns, and now it's negative down here. So this is all decreasing. So I've got an interval at -1, 0. Let's find the other interval. Let's calculate the 0 again. And I'm going to move over here. I just need to be on the left-hand side of it. And over here where it crosses, I'm going to get on the other side of it so I can calculate it. And there it is. 1.9999. Now, 1.9999 like that, I'm going to round it. And it's going to be 2, 0. That's our other interval we're going to look at. So that means that at 2, not at 2, 0, sorry. At 2, there is another turning point right about here. And you can't really tell that on the graph, can you? It's like, I got to kind of look at that. Okay, there's one more over here. The graph is, second calculate, the 0 again. I'm going to get on the other side of it, so that's good. And then I'm going to move all the way over past the other 0. There it is. Let's calculate that 0 right there is 6, 0. Okay. Those are the areas where the graph switches. Now going back from this is the derivative. This is not the graph of my function. This is the graph of the derivative. This gives me the information I'm looking for. The zeros are the turning points of the graph. And you may want to jot that down somewhere. The zeros of the derivative are the turning points. That's what this is. The zeros are the turning point. The derivatives are the turning point. So from -1 to 0, we're going to look at that. And it makes sense. We're increasing, 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 and then we hit a turning point, and then we decrease and decrease, increase until there, and then we decrease and decrease until down here at 6, 0. Not 6, 0, but at 6, and that's our next one. So what I need to do now is I need to figure out at x equals -1, where is my graph? -1, it kind of looks like 1500. I'm not really sure, but what I'm going to do is go back here. Well, I really don't want to delete that graph because it took me so long to put it in. I'm going to put in the original now. So 4 x housetop 5 move to the right, minus 45 x housetop to the 4th move to the right, plus 120 x housetop 3 move to the right, plus 40x housetop 2 move to the right, minus 480x plus 1200. Okay, now just another reminder on your calculator what you can do. Remember, you can go to the equal sign, hit enter, and it will unhighlight it, and that way when I graph it, it won't graph that one. And you're going to notice my graph is going to look just like the one on there, right? Now, I already know the turning points. I wasn't for sure, and I'm going to show you both ways. So let's calculate a value, and the value we want is x equals -1. When x is -1, it says I am at 1,551. Okay, now let's calculate a value when x equals 2. And that value is 768. And the other value, and I can see that's a turning point. Second, calculate a value, x equals 6. And at 6, it says we're at -1,536. Those are my turning points. Those are my stationary points where my graph switches from one direction to the other all throughout this graph. Now, I want to show you from Algebra 2, what if I just calculated the maximum right there? What if I said second calculate the maximum? Oh, I hit the button. Okay, escape. Second calculate the maximum. And I'm going to move my cursor over there. I'm going to find it. There he is. Ooh, come on over, man. I'm going to put it on the left-hand side. Move it over on the other side. Here it is. 1.00001. Okay, that's like 1,551. Is that not what I got? Sure is. Okay, now I know the other one is over here, but let's say I wasn't sure. I could move, I can second calculate, and I would call that a minimum because that's kind of a low point. I'm just going to mark the left, and I'm not sure where it is, but I know it's somewhere over there, so I'm going to do over here to the right. It is at, oh, look at that, guys, 2.583. Okay, so let me try that again. Maybe I did something wrong. So let me do the minimum again, and it looks to me like the minimum somewhere in there. So I move over here, and I do it again. Do you see how that one, because of the way the graph is, it's kind of hard to tell where the low point is. You know it's somewhere in here, but you're not sure where. The only way to be exact is to actually know how to find that spot. Now, it does work on the other spot. If I go calculate the minimum, and I go from right here all the way over to this side, it'll calculate that minimum, 6.00008. Well, that's 6. Negative 1536. So it worked on that one. Where it doesn't work is this right here. You can't figure out the exact low. If you can, great. You can use your Algebra 2 skills on that to find that. And it actually works. All right, so here we go. Here's the next example. Oh, I'm going to move this up a little bit. Find the minimum point of the graph of y equals 1 over 12 minus 2x to this over 2 over x to the 6 for x greater than or equal to 0. So I even show you on here, like it's right there. So we've got the graph. Let's see if we can do this one without having to use our derivative. Oh, it's painful to delete that. It took forever to type in 1 over x to the 12th, move to the right, minus 2 alpha y equals 2 over x house top to the 6th. Let's graph it. All right, so when you look at that, you're like, wait, mine doesn't look like that because they're only doing this little section. Okay, so I'm going to do window, and I'm going to do, let's do zoom 6. Get that standard zoom. And so I kind of want to zoom in on that area right there. So I'm going to zoom in. I'm going to go right over here to that area. There we go. Now, they're just doing that little area right there. So, can I calculate the minimum? Let's see if I could just do it just by second calculate minimum. I'm going to go over here. Left-hand side. Over to the right-hand side. 1, negative 1. All right, well, that ordered pair right there is 1, negative 1. Is that the lowest one? Yeah, pretty certain that is. That one didn't, how can I do this one this way and the other one the other way? I could do this one the other way if I wanted to. I would take the derivative of this. And so if I did that, remember when you take the derivative, you have to have it in x to the power. It can't be a fraction like we've got on this one, minus 2x to the negative 6. So when I do y prime, I'm going to give you just a second to try and do it. I would have negative 12. I would reduce this by 1, so that would make that negative 13. Negative, negative, that would be a positive 12, x to the negative 7. Okay, so I end up with that. Then remember what we would do is we would go y equals, I'm going to turn this one off. I'm going to go here, hit enter so it doesn't graph it. And I'm going to do negative 12 x house top negative 13 plus 12 x house top negative 7 I'm going to graph that one, and I may have to zoom out. I may be zoomed in too much. Oh, no, I can see pretty good. So remember, the zeros are where you have a turning point. So second, calculate the 0. Let me get on the other side. Oh, okay, get below it. Get above it. Oh, look, it's at 1, 0. So that means at the ordered pair 1 something, my graph has a turning point. So I would go to y equals, I'm going to turn this one off. Now I'm going to hit enter. I'm going to go back up here and I'm going to turn it on. And I'm going to graph it. And I need to calculate the x, when x is 1, what is y? So I'm going to do second calculate a value at x equals 1. 1, negative 1. So that's using the derivative, but on this one, it's pretty easy to just use your algebra skills and find that one. All right. Find the value, the smallest value of f of x equals x over 2 plus 2 over x. Oh, you know what? I drew a line through this one. I think we're not going to do that one. Oh, I thought I took that. Oh, that's a different one. Sorry. Yes, we are doing this one. Okay, so here's what I want you to do. I want you to graph this one. Find the smallest value of f of x equals, the smallest value, isn't that just going to be the minimum? Yeah, so here we go. Let's clear all this out. Let's put in alpha y equals x over 2 plus alpha y equals 2 over x. Let's graph it. Now, important to note, for the interval 1 to 5, it only wants that interval. So what I'm going to do is go to window. It only wants x equals 1 to 5. Okay? Here's what I'm going to do. I'm going to actually make this, I go 1 above on each side. So I'm going to do 0 to 6 so that way I can see it. Oh, you know what? I should probably go up a little bit. There we go. Okay, so there it is. Oh, from 1 to 5, that's not bad. So this graph looks like this. All right, let's graph the derivative. Can I see this? Can I see the minimum? Kind of looks like it's going to be about right there. Let's just see. Let's see if we're able to calculate it. So let's calculate the minimum. Let's go all the way over here. Let's make sure we get the right one. And then let's go way over here when we can definitely tell that it is going up. Okay, it's definitely climbing. So it is at 2.0000, so it's at 2, 2. So the lowest point on the graph is at 2, 2. I'm going to label over here 2, 2, and it works. Now, I could have taken the derivative and then found the 0 of the derivative and it would have worked. But if my graph allows me to use algebra instead of calculus, then I want to definitely do that. All right, the next one is optimization, and we'll do another video on that.